This video deals with vertical shrinking, and I want you to note the general formula for tan graph here, where we have A times tan theta, B times theta minus H plus K. So in this case, if we look at the graph of G, which is half tan theta, then the A value is equal to a half, whereas B is equal to 1, H is equal to 0, and K is equal to 0. So we have to note that we're busy with the general formula, but we're only dealing with the A value now. So if I look at the A value, I remind myself that tan theta is this green graph, the mother graph, and that I now have to multiply all the vertical or all the y values, multiply by half, or the y values divide by 2. So if I look at the point B, E, H, and K there, B, E, H, and K there, I see all of them are 0. So if I take 0 and divide 0, then I will get 0, 0, 0, 0. If I take the values at C, F, I, and L, then I see, but all of them were value 1. So if I take 1 divided by 2, I get a half. I make a dot. 1 divided by 2, 1 divided by 2, 1 divided by 2, and I get the new dots N, P, R, and T. If I look at the values at A, D, G, and J, which are all minus 1, then I take minus 1 divided by 2, I get minus a half. Minus 1 divided by 2, I get minus a half, which is at O, and minus 1 divided by 2, which gives me minus half at Q, etc. So now we've made our dots, we remember what the general form of the graph is. You can use other values and divide that by 2, it doesn't matter. But if I have these three values, those at minus 45 and at plus 45 and multiples thereof, 180's multiples thereof, then I just need to bear in mind what the general graph of tan theta looks like. So if I look, for instance, in the first quadrant, I will have this graph, and because of the small space we have, it looks as if the graph of half tan theta will intercept at somewhere here or somewhere down there, but we must investigate whether that is the case or not. On this page, I've just joined the dots, and you can see that the graph is just sort of squashed or vertically shrinked, but it did not change the period of the graph, and the roots even did not change. So the period is still 180 degrees. Again, we have no amplitude, and again the roots are at B, E, H, and K, or the roots will be, or the intercepts with the horizontal axis will be minus 180, 0, 180 degrees, and so forth. So in general, we can write down the roots are K times 180 degrees, K element of Z, and please check your formula. So again, we know there's no extremes because we don't have a minimum, we don't have a maximum, because plus infinity, we cannot pinpoint where plus infinity is. It is a very large number, but suppose we choose a very large number like 1 million, then 1,000,001 is larger than that, etc. If I pick 1 trillion, then 1,000,001 is larger than that, etc. So we can't pinpoint it, so there is no extreme. When we look at the vertical asymptotes, and again we can write down the vertical asymptotes, a formula for that, and we had it before. We say theta equal to 90 degrees plus k times 180 degrees. And we rewrite that as 2k plus 1 times 90 degrees. The reason why I write this step again is to give you sort of something to hold on, because you need a starting point, and the starting point is 90. And how do you get to the next one? You add 180 degrees. From there onwards, you can write down a nice formula. But it's not necessary to start there, to memorize that. It's necessary to memorize or understand the concept. Where did I start and how did I get to the next point? Okay, so let us look at the concavity. Again, you can see here it's much more obvious how this function is concave down below the horizontal axis and concave up above the horizontal axis. So remember that we need to know about concavity because it influences the shape of the graph. On this page, we again have a summary of everything that happened, and you can work through that. The only thing that you have to again note is that we draw a broken line for the vertical asymptotes. Without the vertical asymptotes, we will not be able to indicate how far down this graph goes, and it is necessary to draw it in. I just want to quickly show you where the tan graph and the half tan graph will they intercept. So let us see. If I look at a half tan theta and I equate it to tan theta, it will reduce to a half tan theta equal to 0, or tan theta equal to 0. And that is where we get the roots. So the roots are at the same place, but there are no other values where these two graphs will ever intersect each other.